Something very strange happened at the Chinese Grand Prix. Mercedes did not just win. They dominated the entire weekend. Pole position, sprint victory, and a commanding 1-2 finish on Sunday. But a few minutes after the race ended, engineers from rival teams started looking at the data. And what they saw immediately raised questions. Because on the longest straight in Shanghai, the Mercedes engine behaved in a way that no other car on the grid could replicate. While every other team suffered energy drop near the end of the straight, the Mercedes kept accelerating. Smooth, constant, no visible loss of power. And according to several paddock insiders, this could be linked to a controversial engine deployment trick hidden inside the 2026 hybrid system. If that is true, it could completely change the championship fight this season. Because under the new regulations, managing hybrid energy is one of the biggest performance advantages a team can have. And right now, Mercedes might be doing something the rest of the grid still does not fully understand. So the real question is simple. Did Mercedes simply build the best engine in Formula One? Or were they just caught using a loophole that nobody noticed until the Chinese Grand Prix? Subscribe to the channel, because what engineers discovered after this race might become the biggest technical controversy of the entire 2026 season. At first, nobody in the paddock thought much about it. Mercedes winning races is not exactly new. But what happened in Shanghai felt different. From the very first practice session, something about the W17 looked unusually comfortable. Russell topped the timing sheets. Antonelli followed right behind. And the gap to Ferrari and Red Bull was not small. Sometimes it was several tenths of a second. Now, in Formula One, a few tenths is massive. That kind of margin normally takes weeks of development to find. Yet Mercedes arrived in China already looking faster than everyone else. And that is where the first question started. Because the dominance was not limited to one specific part of the lap. The car was stable in corners. Very precise through direction changes. But the real difference appeared when the drivers exited the final corner and accelerated onto the long straight. Every lap told the same story. Ferrari would stay close through the technical sections. Red Bull would hold the gap through the middle sector. But the moment the cars entered the straight, the Mercedes suddenly found extra speed. Not a small advantage. A visible one. Cars behind simply could not stay within slipstream range. And that detail became impossible to ignore during the sprint race. George Russell started from pole position. Charles Leclerc stayed within striking distance during the opening laps. The Ferrari looked competitive through the corners. But the moment they reached the back straight, the Mercedes pulled away again. Smooth acceleration. No hesitation. No visible drop in hybrid deployment. Russell controlled the race from the front, managing the gap with surprising ease. For Mercedes, it was the perfect confirmation. The car was fast in qualifying, fast in race pace, and incredibly efficient in energy management. But while the team celebrated the sprint victory, something else was already happening behind the scenes. Engineers from several rival teams had started reviewing the onboard footage. Not the highlights. The raw telemetry. The sound of the engine. The behavior of the energy deployment during long acceleration phases. And the deeper they looked, the stranger it appeared. Because on the longest straight in Shanghai, every Formula One car follows the same basic pattern. Full acceleration at the start of the straight. Strong electrical deployment. Then, near the end, the battery begins to run out. Power drops. Acceleration flattens. Drivers call it clipping. It happens to every team. Ferrari, Red Bull, McLaren, everyone. But the Mercedes cars did not seem to suffer from that problem. Lap after lap, their power delivery remained almost perfectly consistent. Which leads to a very uncomfortable question for the rest of the grid. How exactly are they doing that? And more importantly, is it something the regulations actually allow? Because according to multiple engineers inside the paddock, the way Mercedes deploys its hybrid energy might involve a clever interpretation of the new 2026 power unit rules. Not necessarily illegal, but potentially controversial. And here is the part that makes the story even more fascinating. Most fans watching the race completely missed the clue that revealed this possible advantage. It happened during the very first lap of the Grand Prix. And once you notice it, you cannot unsee it. The clue appeared only seconds after the race began. Lights out in Shanghai. The cars launched toward the first corner. Lewis Hamilton reacted perfectly. The Ferrari exploded off the line and immediately squeezed between the two Mercedes cars. For a brief moment, the crowd saw something unexpected. A Ferrari leading the race. Hamilton carried that momentum through the first sector. Perfect traction. Aggressive braking. And as they exited the long sweeping corner that leads to the back straight, he was still ahead. But then something happened that caught the attention of several engineers watching the data in real time. The moment the cars reached the back straight, Antonelli began to close the gap. Not gradually. Rapidly. Within seconds, the Mercedes was already in the slipstream. And then something even more curious happened. Antonelli pulled out of the draft earlier than expected. Normally, drivers wait until the final part of the straight before attempting a move. That way they maximize the aerodynamic tow. But Antonelli moved early. Much earlier than the standard strategy. And despite leaving the slipstream sooner than usual, the Mercedes continued gaining speed. Closing. And then simply driving past the Ferrari before the braking zone. Clean. Effortless. Like the car still had energy available when the Ferrari did not. At that exact moment, several engineers inside rival garages started replaying the onboard data. Because what they had just seen did not match the usual behavior of the 2026 hybrid systems. On most cars, the electrical boost begins to fade near the end of very long straights. The battery reaches its deployment limit, and the internal combustion engine becomes the primary power source. But the Mercedes did not show that transition. The acceleration curve stayed smooth. No sudden drop. No visible loss of deployment. Which suggested something extremely interesting. Either Mercedes had discovered a way to recover more electrical energy earlier in the lap, or they had found a more efficient method of distributing that energy across the straight. Both possibilities are significant. Because under the 2026 regulations, energy management is one of the most restricted areas of the power unit. Every team has the same theoretical limits, the same battery capacity, the same maximum electrical output, which means the advantage cannot come from simply using more power. It has to come from how that power is used. And this is exactly where the story starts to become controversial. Because according to several technical analysts inside the paddock, the Mercedes deployment pattern looks different. Not illegal on the surface, but different enough to trigger serious curiosity among rival teams. Some believe the key lies in how Mercedes combines its active aerodynamics with hybrid deployment. Others suspect the software controlling the power unit is doing something extremely clever during the braking phases. Harvesting energy more efficiently, releasing it more gradually, stretching the available electrical boost just a little longer than anyone else. And in Formula 1, a small difference like that can translate into massive performance. Especially on circuits with long straights. Shanghai exposed it first. But what worries rival teams is something even bigger. Because if this advantage truly comes from a smart interpretation of the 2026 rules, then Mercedes may have just unlocked one of the most powerful technical advantages of the new era. And the rest of the grid might still be trying to understand it. But the real tension in the paddock did not begin during the race. It started after the checkered flag. Because once the cars returned to the garages, the data analysis began. Every team in Formula 1 studies its rivals. Every lap, every straight, every throttle input. Engineers compare onboard audio, speed traces, energy deployment graphs. They look for patterns. Tiny patterns that reveal how another car is producing performance. And after the Chinese Grand Prix, several engineers noticed the same anomaly. The Mercedes acceleration trace on the main straight looked unusually clean. Normally, when hybrid energy runs out, the curve changes. Acceleration drops slightly. The speed increase becomes slower. It is subtle. But engineers can see it immediately. On Ferrari. On Red Bull. On every other car. Except Mercedes. The W17 maintained a nearly constant acceleration profile across the entire straight. Which suggested something very specific. The car was managing its electrical energy differently. More efficiently. Stretching the available deployment longer than expected. Now here is where things become extremely interesting. Because in the 2026 regulations, the electrical side of the power unit has much more influence than before. Nearly half of the total power now comes from the electric motor. That means energy deployment is no longer just a support system. It is a core performance factor. If a team finds a way to deploy that energy more smoothly, more efficiently, even a tiny advantage becomes massive over a full lap. And this is why rival engineers immediately began asking questions. Not publicly. Not yet. But quietly. Inside technical meetings. Inside data rooms. Because the Mercedes power delivery looked too perfect. Almost like the system was distributing electrical energy in smaller, continuous waves instead of one large burst. And if that theory is correct, it would explain everything seen in Shanghai. Why the car keeps accelerating late into the straight. Why rivals cannot stay close enough to attempt overtakes. Why Antonelli could pass Hamilton so easily on the opening lap. But there is another layer to this story. A layer that most fans never see. Because hybrid systems in Formula 1 are not controlled only by hardware. They are controlled by software. Thousands of lines of code. Algorithms that determine when energy is harvested, when it is stored, and exactly how it is released. And within those lines of code lies one of the biggest competitive battlegrounds in modern Formula One. Teams cannot exceed the official limits, but the regulations leave room for interpretation. Small areas where creative engineers can experiment with strategy. And sometimes, those strategies sit right on the edge of what the rules intended. That is why some teams are now asking a very careful question. Not whether Mercedes is breaking the rules, but whether they have discovered something the regulations never anticipated. Something hidden between the lines of the rulebook. Because if that is the case, then Mercedes may not just have the fastest car right now. They may have discovered the first real loophole of the 2026 Formula One era. And if history has taught us anything about Formula One, when one team finds a loophole, the entire grid starts looking for it. But the moment this theory started spreading through the paddock, another question appeared. If Mercedes really found a smarter way to deploy hybrid energy, why did nobody else see it coming? The answer might lie in something much deeper than engine power. Because the 2026 regulations did not only change the power unit, they also changed the entire aerodynamic philosophy of Formula One. For the first time in modern history, the sport replaced the traditional drag reduction system with fully active aerodynamics. Front wings move. Rear wings move. The entire car changes its aerodynamic profile depending on the situation. In corners, the wings close to generate maximum downforce. On the straights, they open to reduce drag and increase efficiency. In theory, every team uses the same concept. But in practice, the interaction between aerodynamics and hybrid deployment is incredibly complex. When the wings open on the straight, drag drops dramatically. That means the car needs less energy to keep accelerating. And this is where some engineers believe Mercedes may have found their advantage. Not by producing more power, but by reducing the amount of energy required to maintain that power. Think about it like this. If two cars deploy the same electrical energy, but one of them experiences less aerodynamic resistance, that car will accelerate longer, faster, and more efficiently. This theory would explain something very specific that analysts noticed in Shanghai. The Mercedes was not just fast at the beginning of the straight. It was fast at the end of the straight, which usually means the car is either carrying more energy or losing less of it. And if Mercedes has managed to synchronize their active aero system with their hybrid deployment strategy, that could create a perfect efficiency loop. Lower drag allows longer acceleration. Longer acceleration allows smoother energy release. Smoother energy release prevents early clipping, which then keeps the power delivery consistent until the braking zone. A small engineering idea, but one with enormous consequences. Because Formula One performance is built on tiny margins. A few kilometers per hour on every straight. A few tenths of a second per lap. Over an entire race distance, that advantage becomes unstoppable. And suddenly the events of the Chinese Grand Prix begin to make much more sense. Why Ferrari could stay close through the corners. Why Red Bull remained competitive in technical sections.